So today we are given this problem 206 of Leetcode, reversed linked list. So given the head of a singly linked list, reverse the list and return the reversed list. Okay. So basically we will be given a linked list and we will be supplied with the head of the linked list. All we need to do is convert this linked list from and reverse it and return the head of it. Now, to solve this problem, we are going to discuss two methods. One is going to be the brute force method, and other is going to be the most optimal method by using pointer. Now, let's first discuss the brute force method of solving this. Now, initially we are given this linked list, right? Now, either we are going to use one stack or a vector, or you can use a DQ or whatever container you have. Now here I'm going to use a stack. Now what we are going to do is, first we are going to perform the first iteration over this linked list and store all the values into the stack, right? So 1 2 3 4 and 5, we stored all the values into the stack. Now we are going to do the second iteration, and in the second iteration what we are going to do is, we are going to pop out the top element from the stack and store it into the linked list, right? So initially we had 1 2 3 4 5, right? Null. So what we are going to, in the second iteration, what we are going to do is, we are going to pop out the top element from the stack and put it in the head. Then we are going to move the temp to the next node and pop out the next element from the top and put it in the put it in the linked list. Then we are going to move next and pop out the next element and put it in the linked list, and we are going to keep doing it until our stack is empty. Now this is a brute force way of solving this. If we have, let's assume we have n nodes in the linked list. So the first iteration is going to consume O of n time, and the second iteration is also going to consume O of n time, and it is also going to consume an additional space complexity as we are implementing a stack or a vector. So this is going to work, but it is going to take an extra time and extra space complexity. Now we are going to discuss a brute force, the most optimal method using pointer. Now in this optimal method, what we are going to do is not change any data in the in the linked list. We are just going to change the pointer of the linked list. So we had, initially we were given 1 2 3 4 and 5, right? And we were given something like this. So initially we were supplied this head, right? All we have to do is change all these links. Every time we are going to iterate, we are just going to change this link and return this as head. So this our problem is going to be solved, right? This will be our head. So so our linked list is going to get reversed, as now 5 4 3 2 1 will be our new linked list, not 1 2 3 4 5 was initially supplied to us. Now how do we do it? Always we need to break big problems into smaller chunks. What if we had head as null? If our head was initially null, so we'll simply return the head. There is no reversal that we are going to perform. What if we had just one node? Let's say our question is given something like this. This is the head of the linked list that we were given and supplied. Now even after reversing, this is going to stay the same, so we'll again simply return the head. So the first line of our code will be, if head is equal to null or head next equals to null, we are going to simply return head. Done. The first line is going to look something like this. Now we are going to complicate and put a complication layer over it. What if we have two nodes? Let's say we have 1 and 2, and we are given something like this, right? Null. Now this is the head. first thing that we are going to do is go to the head and put another new node pointer named current, right? And we are going to assign another pointer named previous. See, previous, and we are going to assign previous to null. So we are going to have current to store the head, so that we move current and we don't tamper with the head. And then we are going to assign previous to null, in u double l null, right? Now what we are going to do is we are going to assign current dot next into the previous. This should be our new approach. Next, and then we are going to do this, right? We are going to not point from 1 to 2, rather we are going to do current next to the previous. But there is a problem. See, if I am even writing this current next, what is current next pointing to? Current next is now pointing to 2, but we want to point to null, so we are going to store it to previous. Now current next is pointing to, now after doing this, current next is pointing to here. But see, there is a big problem here. Now we don't have any access to this data in the linked list, as nothing is pointing to 2, so we won't be able to access 2. So before performing this step of reversing the link from current to previous, we need to store this next value after current into a different pointer variable, so that after this we could access this. So let's name this forward, and before executing this line, what we are going to do is we are going to store forward as current next. So now the forward is pointing over here. We have 3 pointers. One is previous, one is current, and one is forward, right? So initially it looks something like this. So the next line we are going to do is we are going to store current next to previous. So current next is now not going to point to 2, it is rather is going to point to the previous one. Now we have this forward. What we are going to do is shift all of these pointers to the next pointer. So we are going to move previous to here, we are going to move current to here, and we are going to move forward to here, that is null. And we are going to perform the same step again. I'm going to explain you again what we are going to do. Now, as now our previous is here, current is here, we are going to perform this step again in a while loop. Let's say current next will again point to previous. Now current is here, our new current is here, and now the current is pointing to null, but I am setting current dot next to previous. So current dot next is not going to point to null, it is going to point to 1. Now this loop should end at this point, so our while condition will be while the current is not equals to null. Now next we are going to move this all 3 pointers again to the next position. So previous will move here, current will move here, and forward will move here, right? Now see, previous is pointing to 2, so this is our previous. Current is pointing to null, right? Current is pointing to null, and forward is pointing to after null. So watch, now current is pointing to null, our loop is going to break. So this so our link is actually reversed. We have something like, after reversing, we have something like this. We had null here, and we have null here. 1 is pointing to the null, 2 is pointing to 1, and we are our 3 pointers are currently at here. Here we have previous, null we have current, and another forward pointer is out of the scope. Now we need to return the head of the linked list. Now head of the linked list, we need to keep in mind that the head of the linked list is not current. The head of the linked list is previous, as previous is pointing to the last node. Our loop is breaking at while current is not equals to null. So when current will be equal to null, the loop is going to break. So when current will be equal to null, previous will be at the last node. So our pointer, our head, our linked list will look something like this: null and 2, and this will be our previous, and we are going to return previous, and our link will all the link will be reversed. We can take a bigger example and it will still work. So what we could do is write the code of it. While current is not equals to null. While current is not equals to null, what we are going to do is, the first step of it is we are going to set the forward pointer before moving the current next to previous, because if we move the current next to previous, our forward pointer will get lost because we won't be able to point to 2 if we don't store it. So the first step would be that current next store this into a pointer, current next store this into a pointer forward. All right, current next store this into a pointer. I'm drawing it here again. So let's say this is current and this is forward. We stored this into a pointer forward, right? And we have null here. Now after this line, what we are going to do is we are going to place the current next to previous. Before the while loop, we are going to define previous to null, so we will have null as previous beforehand. And what we are going to do is set current next to previous. Now current next is going to point to previous and this link is going to get lost. Now this to line is simply going to change the next pointer to the previous pointer. Now we are going to write more two lines, so that we shift this previous to current, current to forward, and forward to the next. What we are going to do is really simple. Set previous to current. All right, now the previous is here. Now set current to forward. So the current is here. Now we don't have to write and increment the forward to the next, as the first line forward is equals to current dot next. Our current will be here and current dot next will be our new forward. So forward will automatically go to the next node if our node exists, and we are going to, and our loop is going to be this one, and we are going to run this loop till current is not equal to null. So when the current will move here, our loop is going to break, and we need to remember that we are not returning the current, as current will be null and loop is going to break. So we will return the previous as when. So I'm going to say it again. This is our last node and this is null, right? So at the end, at the last condition, what we are going to have is our current is going to point to null and previous is going to point to the last node. So we are going to return this previous. So this will be our head of the linked list. Now we are going to take a quick look at the code. So I have explained the code. It simply does is that if head is equal to null or head next, that means simply we have just one element, we are simply going to return the head. Or else I have defined 3 pointers. One is current, previous, and forward. Previous forward I have set to null. I ran a for loop, a while loop. The time complexity would be going as we are running just once on the linked list, and set the forward to current dot next, as we need to first point out the forward. Then we set the current next to previous. Then this to line, actually what this to line does is the changes the link from current to previous, right? We have current and we have previous, and what it does is changes the link from current to previous. Now after changing this, we are using this to line to change the pointer to the next pointer. So we are setting previous to current and we are setting current to forward, and at the end we are not returning the current, we are returning the previous as the head of the linked list, and our linked list will get reversed. And talking about the time complexity, this is going to take around O of n time complexity, ignoring all of these lines as constant one. O of n time complexity, and space complexity will be also On, where n is the number of node in the linked list.